Okay, we're going to start these introductory videos with just a quick kind of overview of what cognitive psychology is as a field, and some history of how we got here, and a preview of some of the research methods commonly used by cognitive psychologists. So in general, this will just be kind of setting the stage for upcoming topics that we'll dive into deeper, and it'll give us some common terminology that will be useful going forward. So if you crack open any psychology textbook, right near the start, you're going to get a definition. What is cognitive psychology? So for example, one textbook says, it's the study of how people perceive, learn, remember, and think. And that's not wrong per se, but it's basically just a little list of some topics. And indeed, we could expand on that list based on some of the chapters you would find in basically every cognitive psychology textbook. So to perception and memory, we could add attention and consciousness, or intelligence and problem solving, and decision making, and language, and all the stuff you see here. So in another textbook, you might get something that's not just a list. It might be cognitive psychology is the study of mental operations that support our acquisition and use of knowledge. Still pretty darn broad, right? Acquisition and use of knowledge kind of covers most of what we do as organisms. Or you might see a definition like this, the study of what information gets used in various processes and how. But really, that's just aiming back at that list of topics below and asking about the information processing that's involved in those things. And really, that's what cognitive psychologists are doing. We're looking at how our mind or brain processes information to do all of these mental tasks. But what if you want to get just a feel for cognitive psychology? It might help to just see some examples of the kinds of questions a cognitive psychologist might research. So, for example, why do we remember some things and not others? Or what is forgetting? Does information just kind of decay away in our brains over time? And what causes us to be so overconfident in our memories that sometimes we have false memories? So here's a quick example from one study of false memory by a researcher named Elizabeth Loftus.
One of the things that I and my colleagues did is to try to get people to remember that they met and shook hands with Bugs Bunny at Disneyland. This would be impossible because Bugs is a Warner Brothers character and wouldn't be allowed at Disney.
Okay.
Yeah. So how do we get people to believe that? We give them an ad to evaluate. So here's a fake ad for Disney, and you can see Disney in the castle, and there's Bugs. And they review the ad. They just tell us how much they like it. Do they like the colors? Do they like the layout? But later on, when we say, tell us about one of your childhood trips to Disney, which characters do you remember meeting? Do you remember meeting Mickey Mouse, Minnie Mouse, the Little Mermaid, Bugs Bunny? We will get lots of people to tell us they remember meeting Bugs. Oh. And then when they get pressed for details, they'll say they shook his hand, they'll say they touched his tail, they'll say he was eating, one said he was eating a carrot, one said, a few said he said...
So it becomes real.
It becomes real. They embellish it with detail, and it looks every bit like a real memory.
Yeah.
Even though it couldn't have happened.
So that's an example of a cognitive psychologist studying memory stuff. Or a cognitive psychologist might ask, what kind of mistakes normal people make in their thinking? Like, we've got some thinking errors and biases that make us kind of irrational sometimes. Why is that? And can we minimize those thinking errors? Just for example, we might study cognitive biases in judgment and decision making, like one called survivorship bias, where we only kind of notice the story of the lucky ones that survived, but we don't see all the people that failed along the way, or all the examples that didn't come to fruition. So this comic from XKCD gives the idea. The guy here giving his little TED talk says, never stop buying lottery tickets. No matter what anyone tells you. I failed again and again, but I never gave up. I took extra jobs and poured money into tickets, and here I am, proof that if you put in the time, it pays off. Now, hopefully you don't find this too convincing, right? Because we're just hearing from the one person who lucked out, but we don't see the hundreds of millions of times when a ticket was purchased and it led to nothing, or all of the other people who put their life savings into lottery tickets and got nothing out of it and felt horrible about it afterwards. So as the author here puts it, every inspirational speech by someone successful should start with a disclaimer about survivorship bias. This, by the way, is especially true for things like business, where most new businesses fail, but people underestimate they kind of overestimate their odds of success. They underestimate their odds of failing when they start a new business, because we tend to only see the successful ones, right? The ones that survived. Likewise, when a company that offers stock portfolios tells you about one of their funds that has some amazing 20% returns across the last 5 years, you don't realize they may have simply had a bunch of different funds, some of which did poorly and some of which did well, but entirely due to luck. And they simply close down the funds that didn't perform well and leave up the ones that got lucky so they can say, yeah, look, it looks like we can pick stocks really well, but actually it's just survivorship bias at work tricking us. Meanwhile, another cognitive psychologist might ask something like how we use imagination to think. Like, what does it mean that we can imagine a possible future or a contrafactual past, like how things could have gone differently? Or how does that change our decision making? What role does imagination have in problem solving? And what parts of the brain are active when we're imagining something? So that might be a different cognitive psychology topic. Another might ask, why are we so good at guessing what other people actually mean? Like, we humans often use sarcasm, right? And yet we can understand what someone's saying even when the message they're conveying is the opposite of the literal meaning of their words. So cognitive psychologists study things like the psychology of language, sometimes called psycholinguistics, which means they might also ask, why do people say what they don't mean? Even with something like a slip of the tongue, right? We make minor errors during our speech that are predictable, and they happen because of how the brain handles linguistic tasks. So we can understand that by looking at the errors people make. Others might ask things like, how do children think? How do they progress to thinking more like adults? In other words, cognitive development. That's the overlap between cognitive psych and developmental psych. For example, we might investigate how children start to understand conservation, that the amount of something doesn't change just because the appearance changes. So here's an example.
Can you look at these two glasses? Do you think that they have the same amount of juice? You think they have the same? Okay. Now we're going to pour this juice into this glass. Now, do you think that this glass has more juice, this glass has more juice, or do you think that they have the same amount?
That one has more.
This one has more, and why do you think that this one has more?
Because it's taller.
So first we're going to look at these two cups right here. Do you think there's the same amount of juice in this glass as there is in that glass?
They're even.
They're even? Okay. So we're going to take the juice from this glass and pour it into this one right here.
Okay.
Okay, so now we're going to look at this glass and that one. So do you think that there's more juice in this glass, more juice in this glass, or do you think that they have the same amount?
Same amount.
Okay, why do you think that they have the same amount?
Just because this is skinny doesn't mean it's not the same amount. It has the same amount of juice in it, but this one is just wider and this one's skinnier, but they have the same amount of juice in it.
So that's studying the development of cognition. Or we might ask about, like, what is an unconscious process? What is consciousness in general, right? And there's a whole peer-reviewed journal called Consciousness and Cognition that's dedicated to this topic, where you might see cognitive psychologists publishing titles like this, like Individual Differences in the Tendency to See the Expected, or The Attentional Blink Unveils the Interplay Between Conscious Perception, Spatial Attention, and Working Memory, or Brain States Matter, or Multi-Method Exploration of Non-Conscious Prioritization Processes. Or you might see titles like Structure in the Stream of Consciousness, or Consciously Monitored Grasping is Vulnerable to Perceptual Intrusion, or The Influence of Valence on Episodic Future Thinking, and a bunch of other stuff. Just kind of the intersection of psychology with neuroscience and philosophy of mind, sort of an interdisciplinary way of doing cognitive psychology. Other cognitive psychologists might study beliefs, like why some people believe conspiracy theories and why misinformation catches on. Still others might compare human cognition to the information processing done by computers, Like, what do we do better than computers, at least at this point? Or what do computers do better than us already? And what will artificial intelligence look like in the future? Or comparing human cognition to animal cognition. Like, humans have language. Do other animals have language? We can train chimpanzees to use their hands in what basically seems like sign language. Is that actually language? That's something we might study. Others might research things like the limitations of our cognitive abilities, like how much can we train and learn, or individual differences between people, like how and why some people do better at certain cognitive tasks than others, like whether or how those things can be taught or changed, or ways in which we might use different strategies to solve the same kind of problem. Like, different people might use different strategies in problem solving. So a cognitive psychologist studying problem solving, maybe they might investigate using tools that are basically just kind of brain teasers, like this one here. So in this one, we could say, can you connect all 9 of these dots here with 4 connecting straight lines without lifting your pencil from the paper? So you put this in front of someone on a piece of paper. You say, can you connect all 9 of these dots? But you have to do it with 4 straight lines that are all connected without lifting your paper. So you might pause the video and actually try and solve this before I give the answer. Well, the answer requires thinking outside the box, kind of literally. And one barrier to problem solving that cognitive psychologists have studied is something called functional fixedness. Basically, where you have trouble thinking outside the box, where you see things one way or understand an object to have a particular function, so you're likely to miss the alternative solutions or the alternative uses for the object. In fact, a classic example of this kind of cognitive study, way back in the 1940s, it asked participants to attach a candle to a wall using only these items given to them: some matches, a box of tacks, and a candle. So you might pause the video and see if you can solve this before I give the answer. How would you use this stuff to attach a candle to the wall? Now, most people initially struggle when you hand them these items, but that's because they don't think about using something like the box that the tacks came in. Their functional fixedness sees it simply as a container for the tacks, not an item to be used in the solution. But once that clicks, right, once people realize that, they quickly devise a working solution. So cognitive psychologists, they study problems like this, not just to see how quickly people can solve things or who solves it better than others, but to understand the basic principles and thinking processes that underlie problem solving in our day-to-day lives or in our professional lives. And another cognitive psychologist might ask, like, do we have an innate sense of number or math, or what's happening in our head when we solve complicated math problems? Perhaps we answer that by scanning the brain while we do math problems. While others might try to piece together why some tasks are hard and others are easier tasks, or how tasks become more easy over time. Like, how does practice work? How do we automatize things that initially you have to do consciously, but later they become kind of automatic for you? How do you go from having to think that through and deliberately, work a new skill versus it just becomes something you do without paying attention to it? So those are just some random examples to give you a taste for the kinds of things cognitive psychology is about. As you can see, it's a broad field, one that kind of serves as an umbrella over a lot of other fields of psychology, like perception or psychology of language, and one that in some cases overlaps with other fields like developmental psychology. But given all those interesting questions, a cognitive psychologist might ask, how do we go about actually answering those questions? And in general, cognitive psych is a field that's experimental. We focus on the experimental analysis of things, meaning we'll kind of manipulate some cognitive variable, some cognitive relevant task, and then we measure outcomes. So for example, we might record the accuracy of people who were assigned to an experimental condition or a control condition, like the percentage they got correct or the percentage they got wrong, how many mistakes they made, something like that. But also we can learn a lot about what's going on in a person's head and how they're processing information by studying the patterns in their responding or the patterns in their errors. Like when someone mistakenly refers to the electrical college when they mean the electoral college, or makes a spoonerism like saying belly jeans when they mean jelly beans, we can actually come to understand some basic level linguistic processes in the brain from those patterns of errors. That said, sometimes we use totally different kinds of dependent variables. For example, like reaction time, the time it takes to complete a task. In other words, how quickly we can process information, and perhaps how quickly or slowly that goes for different different kinds of processing tasks. Or maybe latency to respond, how long it takes us to respond in different conditions when we've manipulated those cognitive variables as an independent variable. And of course, we'll see other examples throughout this course, like measuring blood flow to the brain using an fMRI machine, or measuring electrical activity in the brain using an EEG in order to better understand, how we perceive or remember or decide or use language. But let's see an example of a very simple cognitive experiment just to get a feel for how we answer cognitive questions experimentally. So one of the most famous historical experiments that could be considered a cognitive psych study comes from F.C. Donders all the way back in the 1800s. So this is before computers, but nowadays we can easily set up the same experiment and do it on a computer really easily. But what Donders did was measure how long it takes to make a decision. That's a cognitive task, right? Making a decision. It's a mental thing. And he showed that decision making isn't instantaneous. We don't just make a decision. There's a whole process going on in our brain when we do even simple decision making. And the time it takes to make a decision can tell us something about different types of decisions, about different types of information processing. So the dependent variable he used in this study, the thing he measured directly, was reaction time, what we're going to abbreviate as RT throughout this course. Now, he started with a simple task. People would literally just have to press a button when a light appears. Again, he didn't have a computer, but we could do it on computer now. So a light shows up, you just have to press a button as quickly as possible. Once the light hits your eyes, right, your brain registers it, you immediately start a motor signal from your brain going down to your finger, and the finger presses a button. Bam! We record how long that whole process took. Now, of course, that time we recorded, that's going to be a combination of how long it took you to process the simple information, but also stuff like how long it took the signal to go from the computer to your eye, from your eye to your brain, and from your brain down to your spinal cord, out your arm, and down to your finger before twitching the muscle. So only some of that reaction time comes from the simple mental process, right? But we're going to come back to that. That's why he added a second condition to his experiment. So he also had a slightly more complicated task for his participants, what we'll call a choice task. In this case, there are two lights. A light could come on either on the left or on the right side. Now, if the light's on the left, you have to press one button. But if it's on the right, you have to press a different button. So now we've still got light traveling to the eye, still have that neural signal having to go from the eye into your brain. We've still now got like something going on in the brain, in this case, something more complicated, right? Because we've got to make a decision of which finger to activate, which button to press. After we make that decision, that little cognitive bit inside the brain, then we've got the usual time of sending the signal down from the brain through the spinal cord to the arm and to the finger to press the button. And Donders is there recording the total time it took. So sure enough, when he compared the two conditions, the choice task took longer on average than the simple task. But based on how he set up this very simple, elegant little experiment, the only real difference in those two conditions that he has is one of them added decision making, right? It added choice, a simple decision, but still a decision to make. So the extra time in that condition must be coming from the mental process of making this decision. You can think of it kind of like this diagram here. In the simple task on the left, we just have to perceive the light, then press a button, and that adds up to our total reaction time. But in the choice task, a little bit to the right there, we've got to perceive the light, yeah, and make a decision which button to press in the middle stage there of brain processing. And then we can measure the total time, right? The motor stuff at the bottom still. So Donders used what we call the subtraction method. We'll see this a lot in this course. Take the average, in this case, the choice task reaction time, and subtract out the simple task reaction time. And that difference, right, the extra time difference in that second condition, the extra time is a measurement of the time it takes to make a decision, to do something cognitive like that. So averaging it all out, he found that it takes about 1/10 of a second to do that simple kind of choosing decision. He measured an internal mental process by cleverly designing this simple experiment and measuring something as simple as reaction time. And in doing so, he actually overturned the commonly held belief at the time that decision-making was instantaneous. No, it's a process. It takes time. There's something going on in there, and we can learn about it or infer it from things like behavior. So a takeaway from his study might be that mental processes, they can't be measured directly. That's true, but they can be inferred from our behavior, like how long it takes someone to respond, or how many mistakes they make, or when and where they make the mistakes they do, and so on. Now, if you want to measure your own reaction time, the New York Times actually put out a fun little game back around one of the Olympics to test your own reflexes and see how it compares to Usain Bolt, one of the fastest runners in the world, who he has to respond as quickly as possible to hearing a starter pistol without jumping the gun and starting too early, because that gets you penalized. It gets you disqualified. In fact, since we know it takes some time for a sound to travel from the gun to your ears and for the brain to register a sound, Olympians can be disqualified if they leave the block too soon after the pistol is fired. Like, they can literally wait until after the pistol is fired and then start running, and they can still be disqualified because we know they jumped the gun, because we know their brain can't possibly have registered the sound yet, so they were doing a false start even though the gun had already gone off. Anyway, here's what that little interactive game looks like if you want to try it. So, let me load this up here. You can see me try and beat Usain Bolt.
On your marks. Set.
Oh, sweet. So I beat Usain Bolt that time, just barely. Okay, let's try it again.
On your marks. Set.
Oh, look at that. I did beat Bolt, and this is after the starter pistol went off that I clicked it, but they're going to say I false started. My reaction time was too fast to be humanly possible, so that would get me disqualified. Like, basically, I was so ready to press the button, I pressed it before my brain had actually processed that sound.
On your marks. Set.
And there we go. I was a little slower than Usain Bolt. You get the idea. So that's measuring reaction time as an example of something we might measure in a cognitive psych study. So we'll stop this video there, but the next video I'm going to go over some common methodology in cognitive psych before we go on to a little bit of the history.